5.6 is about multiplying by a multiplicative inverse to solve equations. Now to begin with, I'm going to, before I introduce the property, I'm going to introduce or review some skills we already know about algebra. So if I was going to solve an equation, oops, let's get to the pencil. If I was going to solve an equation that had the variable that you can't read here. Let's see if we can make that a little bit more legible. Sorry, having some issues here. Here's my 2x, okay? Let's see, have the variable 2x. We know that the rule for algebra is always to solve for a single variable. So 2x means 2 times x. So to get x as a single variable, I would divide by 2. Now we're going to apply this when the coefficient, instead of being a integer or a whole number there, we're going to apply it when the coefficient is a fraction. So let me just, whoops, I'm going to make my screen a little smaller here. Okay, so first of all, we're going to solve a one-step equation. In this equation, you can see that we have variables on the left side and our constant term on the right side. The difference is our coefficient to x happens to be a fraction. So I'm going to change colors here, maybe, so you can see what I'm going to do. So instead of dividing, we just learned in our last lesson, instead of dividing by a fraction, there is no such rule. What we need to do is multiply by its reciprocal. So to get 4/7 to be 1, I'm going to multiply by its reciprocal. And if I do that on the left side, I need to do the same thing on the right side of the equation. Now this gives us some skills that we have learned in chapter 5 already. And if I reduce, 4 goes into 4 once, 4 goes into 4 once, 7 once, 7 once. So I end up with 1 over 1, or just x on the left side. So we did solve for a single variable. Now I'm going to multiply a negative 12 times 7/4. So I'm going to reduce first. 4 goes into 4 once. 4 goes into negative 12. Negative 3 times. Don't lose those negative signs. Or how to write a 3. All right, so now negative 3 times 7 would be negative 21. So we have solved for a single x by using reciprocals to isolate the variable and give it a single variable value. Now we're going to do the same thing. We're going to still apply our algebra rules. This time it's a two-step equation. The reason it's a two-step is because I have a variable and a constant on one side and then only a constant on the other side. So I need to move my constant term. So I'm going to move 4/5 by subtracting 4/5 from both sides. To subtract 4/5, I need to have common denominators. So the common denominator between 1/3 and 4/5 would be 15. So 1/3 would equal 5/15. Negative 4/5 would equal a negative 12/15. 5 minus 12 would give me a negative 7/15. And that's going to equal negative 11/15 x. To solve for x, I'm going to change colors here. To solve for x, a single x, I'm going to multiply by its reciprocal. That will give me x on this side. And I need to do a balanced equation. So I'm going to multiply by 15 over 11 on this side. I have two negatives, so they're gonna cancel each other out. 15 goes into 15 once, 15 goes into 15 once, so they're canceled out. I've canceled out my negative, and so now I would end up with 7/11, and that would be a positive 7/11. Same rules, and now we're applying some of the multiplication rules that we have learned in Chapter 5. Moving on to, whoops, so I skipped one page. We're going to talk about the icicle-shaped stone formations that are found in cave ceilings. They're formed from the minerals deposited by dripping water. So we're going to suppose that one of these icicle-shaped stones is 10 inches long and is growing at a rate of about 1/8 inch per decade. How long will it take for the ice-shaped cone to reach a length of 1 foot? So what I'm noticing first is I have 10 inches. I have about 1/8 inch, and that's a per means multiplying, per decade. And I also have 1 foot. Now I want to first change my feet into inches. And so I'm going to change my 1 foot into 12 inches. So I don't know why I'm getting those dotted ones. I'm going to go ahead and change to the next page and see if that helps. So I took my current length, which was 10 inches. I'm going to add the how much it will grow, the growing rate, and that was 1/8 inch, and we don't know for how long, so that's per. So we're going to go ahead and put X there, and that's going to equal 12, which is our 12 inches, which was 1 foot. So now we're going to go ahead and we're going to solve like we would any algebra. Let's get our constant terms together. So I'm going to subtract 10. Having some problems with the stylus here still. Subtract 10 from both sides. Apologize. We would get 1/8 x equals 2. And now because I have a fraction coefficient, I want to go ahead and multiply by the reciprocal. So it would be 8 over 1, or just multiplying by 8. So now I get that a single x equals 16. And that would mean that it would take 16 decades, which is actually 160 years, because a decade is 10 years, 160 years for it to become 1 foot long, or 12 inches long. And that concludes the multiplicative inverses for lesson 5.6.